Truth, trust, and security. Best practices in Oracle network design. Now, I know security might not be the most immediately exciting topic, but it is one of the most important. Every day, I'm amazed by the power of crypto to change the world and the speed at which it's doing that. Many of us are also painfully aware of the risks and responsibilities that come with immutable, decentralized ledgers. CertiK aims to raise the level of security and transparency across all of crypto. That's a mission we share with Chainlink, and security and transparency will be two key themes of this presentation. At CertiK, we've audited nearly 1 million lines of code. Our team of experts manually review each line in a project. We've also implemented an automated process known as formal verification. Formal verification examines the integrity of a smart contract by calculating every possible value of all of its variables. It's a big step towards removing trust from the auditing process and using the same logic that powers smart contracts to secure them. But for Oracle networks, a code audit is just the first step. While a smart contract audit can verify that the code is sound, when it comes to providing real-world data, there is more to consider than just the code. Blockchains might work according to a set of deterministic rules, but the real world doesn't. And insecure data delivery has major security implications when DeFi protocols secure tens of billions of dollars of value. We've seen too many exploits that have drained hundreds of millions of dollars from the wallets of DeFi users. Each exploit sets the whole space back, hurting the reputation of DeFi and burning the users who contribute so much to driving the ecosystem forward. A number of these exploits have been price Oracle exploits. So how can we design Oracle networks that are both secure and scalable? First, let's define what we mean by decentralized Oracle network. Decentralization refers to a system where the responsibility and authority to perform the system's primary function are shared across multiple independent actors. For Bitcoin, that's the proof of work mining that validates transactions and secures the network. True decentralization works uniquely well at scale, which we saw recently with the exodus of miners from China. The Bitcoin hash rate dropped significantly, but the network didn't suffer a moment of downtime. A centralized network would have had much more difficulty responding to a sudden ban on operations in the country that supplied the largest share of its computing power. The primary function of an Oracle network is to communicate with the smart contracts that live on these blockchains. Oracles speak with these pieces of code, relaying messages to and from the world that would otherwise remain outside the closed system of a blockchain. In deterministic programming language, smart contracts ask quantifiable or binary questions, and oracles deliver the answer. What's the price of Ethereum? Has a collateralized debt position on Aave reached its liquidation point? How much did it rain in Ethiopia last year? And on a scale of 1 to 100, how secure is a certain smart contract? So how do Oracle networks arrive at the correct answers to these questions? This takes us into the question of what is truth, which might be a bit too deep to explore today. But one answer, and the one we'll go with, is consensus, or verifiable consensus. Oracle nodes come to consensus on answers to questions that adhere to social conventions about truth. As I mentioned before, Oracle networks can answer quantifiable or yes-no questions. This means that answers need to be either measured, like the amount of rain in Ethiopia, or calculated, like a position's liquidation point on Aave. Oracle nodes need access to data sources that can provide these measurements, and they need to be able to perform calculations. CertiK actually runs its own decentralized Oracle network. The CertiK Security Oracle provides real-time security scores reported by a decentralized network of nodes. This can help developers ensure that their contracts' interactions with other smart contracts meet an acceptable level of security. The raw data that is used to derive the security score is all available on-chain, but it does not exist in a form that is legible to smart contracts without the Security Oracle. In this manner, the Oracle converts on-chain data into actionable metrics. It's just one security-focused example of the practically unlimited applications of Oracle networks. Another example, perhaps the most critical to DeFi, is price feeds. In crypto, there is no single exchange that determines the price of an asset. Instead, there are dozens, each with different trading volumes. A secure Oracle network will draw from a representative range of these exchanges and weight their price by volume. This is a future-proof design choice that ensures accurate price data as it takes into account the potential for shifts in volume across exchanges. Price oracles drawing from a single source are open to exploitation. These have become known in many cases as flash loan exploits, though despite the fact that many attackers do use flash loans to carry out their attack, any well-capitalized actor could perform the same exploit. This makes them really more centralized price oracle exploits. For example, in November 2020, more than $86 million was liquidated on a major DeFi platform. The price of DAI on Coinbase, which functioned as this platform's sole price oracle, was artificially pushed up to $1.50, not something you'd expect from a stablecoin. Notice the relationship here between truth and security. In this instance, they're pretty much one and the same. This one market deviated from the broad consensus about the price of an asset, and the result was a security failure to the tune of nearly $100 million. This highlights the importance of decentralized oracles with broad market coverage and shows how oracle security goes beyond the code just functioning as intended. There are many external variables to take into account before having a meaningfully secure oracle network. So it's clear how users benefit from the data provided by secure decentralized oracle networks. For example, they don't get liquidated when they shouldn't. But how can data providers benefit too? By securing the consumption of quality data, Oracle nodes also incentivize its production. Selling access to premium APIs is one option for enterprises. This data can then be delivered to on-chain smart contracts by Oracle nodes. But for those forward-looking companies that have valuable data, they can profit directly by selling it via the operation of their own node. But we're still in the early days, and not every data creator in the world has signed up to become an Oracle node operator. Even if they did, third-party nodes that draw from a range of sources and aggregate the results will still play an important role. For example, if Coinbase ran a node in a decentralized Oracle network, it would still have reported the incorrect price of DAI from the previous example. Verifiable consensus requires multiple sources of truth. So how can an Oracle network become a source of definitive truth in an environment where there are often sizable incentives for dishonesty? The answer, or an answer, is reputation, though not quite in its current form. While centralized organizations leverage the strength of their brand and often their power to obfuscate the internal workings of their systems, decentralized networks are judged on one thing alone: their track record, or tracked record, since it's all visible on the blockchain. Oracle nodes build up their reputation by answering requests on time and accurately. And bootstrapping an Oracle network greatly benefits from the creation of a reputation system so that customers can use transparent, meaningful data to inform their choices. Without an objective performance history, we end up back at the just trust us way of doing things. With each job that they fulfill, nodes implicitly stake their reputation on the line. And with explicit staking, they'll be backing up their claims with cold, hard crypto. Here, we've got a screenshot of Linkpool's recent performance, taken from market.link. This reputation system allows prospective clients to select nodes that meet their needs and fit within their budget, creating their own custom Oracle network. At a design level, Oracle networks should be flexible, allowing for users to set their own standard of truth. Latency, decentralization, budget, amount of stake required, all should be able to be set by the user and accommodated by the network. Now, we also face this issue of reputation at CertiK. Most people aren't really technically proficient enough to read a platform's code before interacting with it. Most people probably don't even read the audit report. They trust a project who's been audited by a reputable security firm with a proven track record. This kind of trust is fine. It's basically inescapable in navigating everyday life. But it's not ideal. It works fine until it doesn't. We'll get into the alternatives to that soon. Transparency creates integrity, which creates reputation. Data is reported on-chain, cryptographically signed by its source, where it can then form the basis of a meaningful reputation. This is where the trustlessness of crypto overlaps with the world of brand-based trust. It's a somewhat complicated relationship, as blockchain aims to replace the world of trust-based promises with math-based promises. But in a world where a lot of truth is still very much social consensus, well-known brands and enterprises still have a lot of power. That's why big name data providers and established telecommunications companies becoming Oracle node operators is a reason to celebrate. They're bringing expertise and experience, and just as importantly, the reputation for both of these things. As the saying goes, knowledge or truth is power, but the relationship goes both ways. Power can become truth. Would you rather that power belong to a centralized entity or to a decentralized network of nodes incentivized to reach verifiable consensus? Moving from a world of trust-based promises toward one built on math-based promises is a multifaceted process. But already, hybrid smart contracts powered by cryptographic truth are providing an alternative to many people who before had no option but to accept the cards they were dealt. For example, let's take stablecoin issuer Trust Token's utilization of Chainlink's proof of reserves. The well-regarded accounting firm Armanino attests in real time to the balance of Trust Token's bank account via an API that is queried every 30 seconds. If the balance matches or exceeds the value of all TUSD in circulation, then each stablecoin is one-to-one backed. This is a huge step forward for transparency and security in DeFi. Developers can, for example, implement a circuit breaker that pauses lending on a platform if the peg breaks. And holders gain a level of assurance that their stablecoin is backed by real dollars in a real bank account. Up until now, stablecoin reserve audits have been very much of the just trust us variety. And some of the largest issuers have been reluctant to even publish proof of their reserves in the first place. Cryptographic proof of reserves is a powerful way to raise the level of transparency in crypto. It lives up to the ethos of don't trust, verify, and is a big step towards a future where the little guy does not have to be on the losing end of information asymmetries. You don't need to blindly trust someone's word that their stablecoin is backed. You get cryptographic proof directly from the bank itself, which could even be publishing its own proof of reserves to show that its clients' balances are appropriately backed. Looking forward, technological developments such as zero-knowledge proofs can make this an even more powerful feature. Privacy might not be so important for a stablecoin issuer such as Trust Token, but imagine how important it is in commercial transactions. You don't necessarily want to be broadcasting your bank balance to your competitors. Zero-knowledge proofs can provide a cryptographic guarantee that an account balance is equal to or greater than a certain figure without revealing the exact balance. Soon enough, digital truth will be determined by the node operators and data providers of decentralized Oracle networks. Their reputation will be determined by their accuracy, latency, uptime, and other metrics, which are all reported in real time on public immutable chains. The parties to a smart contract will use zero-knowledge proofs to demonstrate to each other that they are solvent. Cryptographic proofs eliminate the need for trust in every step of the process that comes after the actual creation of the data. And in many cases, it can provide guarantees about how that data was in fact created. During this transition from brand-based promises to math-based promises, from trust to truth, reputation will play an important and evolving role. There's so much progress being made in the space, it's sometimes easy to forget that we're still so early. Chainlink launched on mainnet a little over 2 years ago, and CertiK's security oracle went live last year. I'm excited to see what the next 5, 10, 20 years hold, and it's extremely encouraging to meet many of the talented people who are working on making the world a fairer place. To close out, I'll just say that we should all make security a priority in everything we do in crypto. For the space as a whole to reach the heights we all think it's capable of, security needs to be built in from the ground up. Demand that a project be audited before you invest in it. Seek out projects that take security seriously, and keep supporting decentralized Oracle networks. I think the best is yet to come. Thank you.